Okay, so P7.5, activity and half-life. And if you remember, we said that right at the very start of this module, that radioactive means always active. It means it's always emitting radiation, and that there is nothing that you can do to affect how much radiation it is emitting. But there is one thing that the activity rate depends upon, and that is how many radioactive nucleuses you have, or nuclei that you have. And that would decrease as it is as they're getting used up. So what we do is, if we look at a graph of count rate, and what we're talking about with count rate is how many radioactive emissions are we counting. Okay, so that would be count rate. And what we need to do is we need to make sure that we're looking at the count rate and how that changes over time. Okay, so count rate and time. And let's say we start off with 600. Let's say we start off with a count rate of 600. So 600 here. And then what we do is we would keep recording over time how that count rate is changing. And what you'll notice is, you'll notice that it's got a curve. And that type of curve is called it's got a special name, it's called exponential decay. And all that means is that the count rate will keep going down, but the rate at which it keeps going down will get less and less and less. So what we need to look at now is, how can we use that kind of information? Well, the first thing that's most interesting is, if that is 0 and that is 600, and this is 300, then that is the amount of time. Let's say that was 10 minutes. In this example, this substance here, this source, that we know has a half-life of 10 minutes. So after 10 minutes, it went from 600 to 300. And I also know that after another 10 minutes, it will go from 300 to 150. And then after another 10 minutes, it would go to 75. So that means that I know that after a certain amount of time, how many will there be left. So, for example, if I was to say, if I said that the initial count rate is 1,200, then I know that after 10 minutes I'm going to have 600 left. Then after another 10 minutes, 300. And after another 10 minutes, I'm going to have 150. Then I'm going to have 75. Then 37.5. And then 17. 0.75. Okay, and that would be 10 minutes, 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 that would be 10 minutes. So if I had a source there that I knew started at 1,200 and it now had a count rate of 17.75, I know that it is 10, 20, 30, 40, 50, 60. I know that it is 1 hour old. And that's the advantage of knowing the half-life. You can work out how old a source might be, or you can work out how radioactive it will be in a certain amount of time. Okay, so they're the two uses for it. You can go one way or the other. Now, there's an equation for this, and the equation is that the count rate after n half-lives so the count rate after n half-lives equals the initial count rate divided by 2 to the power n. Okay, where n can be any number. In this example here that I did, it was 6 half-lives. So in this example here, there are 6 half-lives. So in that example, it would be the count rate after 6 half-lives is equal to what the initial count rate was, divided by 2 to the power 6. Okay, and that's how we can work out what that is, and I'm pretty sure that equation is on your data sheet. Okay, so let's give the example of carbon dating. Okay, so carbon comes in 2 major forms. Okay, so you've got your normal carbon-12, which isn't radioactive, and you've got carbon-14, which is radioactive. Okay. Now they've both got the same number of protons because they're both isotopes of carbon, but one of them's got too many neutrons and it gets rid of those neutrons with emitting radiation. When you are living, you are taking on an equal amount of carbon-12 and carbon-14 so that you've got the same percentage. Now I can't remember what the exact percentage is, but I'm going to guess it's around about 80% of this one and 20% of this one. Okay? And as you die, you don't get any more carbon-14, and your carbon-14 turns into carbon-12. So you could work out, so if your percentage of carbon-14 has dropped to 10%, so let's say you've been dead for a while, and your mixture is now 90% carbon-12 and only 10% carbon-14, you can see that the amount of carbon-14 that's in this sample has halved. So you are as old as 1 half-life of carbon-14, and then you can just keep going. And that way we can work out how old something is, because when it dies, this percentage is fixed in place. It's always the same. I've just used 80-20 as an example. And what happens is, as the longer you're dead, you're not taking on any more carbon-14, and your carbon-14 is turning into carbon-12. So the more carbon-12 you have as a percentage, and the less carbon-14 you have as a percentage, the older you are. So if you've only got 2.5%, then you would be 1, 2, 3 half-lives old. Okay, so if you know what the half-life of carbon is, times that by 3, that tells you how old the substance that you've got is.